Unit S, Concept 5, Part 1. We're going to break this into the two parts. The first one is dealing with the half angles. The second part will deal with the double angles. I'm going to work out number 2 and number 4 here for you. The information that you're given on your packets is tangent theta is equal to negative 7 over 24, and that angle is between 3 pi over 2 and 2 pi, and we're trying to find sine of theta over 2. Okay. The first thing we need to look at here is these angles. These are fairly familiar angles to us. This is going to be 0 or 360. And then this one is going to be 270. So this puts us into the fourth quadrant. Okay, what that does for us is it tells us how to draw a triangle. So we got to draw our triangle and making sure it's into the fourth quadrant. So with that, our triangle is going to look like that. Okay, with this being angle theta next to the origin. Remember, if you need to draw this in, that's fine. There's kind of your x and y axes, fourth quadrant, angles always next to the origin. Okay, so what we can do is we can start by filling in our information here. So we know that tangent is opposite over adjacent. So opposite is going to be negative 7. Adjacent is going to be 24. Now how I got that was, if you look on this, your x values are positive and your y values are negative. That's how I got the negative 7 there. Now we need to find the third side here, the hypotenuse, and this just happens to be a Pythagorean triple, so this one is going to be 25. Okay, so that was nice and easy for us. Some of the other ones on this packet you'll have to actually use the Pythagorean theorem. Okay. Now, when we're dealing with our quadrant over here, remember we want to know what the half angle is going to be. So what quadrant is the half angle going to be? And if you use your little section on the top of this concept, it tells you when it's between, when the half angle is between 270 and 360, that the half angle is in quadrant 2, which makes our sine value positive. Okay, so remember, we're still looking at that u over 2, or in this case, theta over 2, where that angle is in the quadrant. So that's that. And sine's positive there, so now we just use our sine formula for the half angle. So sine, and I'm going to use theta over 2 instead of u this time, because it gives us theta, equals a positive 1 minus cosine theta over 2, and that's all square rooted. Okay, let me get some more space here. Now with these problems, there's a little more work. So you're actually going to find some values here. So just be prepared to do some work. Alright. So let me fill in some values here. So this is plus 1 minus, and my cosine value is adjacent over hypotenuse, so 24 over 25. That's still all over 2, still square rooted. Okay, now I can work this. So I'm going to do this top part here. I'm going to break this one into 25 over 25 minus still 24 over 25. So I'm just working out the top portion here. Okay, and I end up with 1 over 25, still all divided by 2, still square rooted. Okay. Now I'm going to multiply by the reciprocal of the denominator. So I get 1 over 25 times 1/2. This is still square rooted. Make sure you don't forget that square root sign. This is going to equal 1 over 25. Now I'm going to use the square root property, the radical property, where I can put the radical on top and the radical on the bottom. Oops, this isn't 25, this is 50. I think I caught that before I started working it out. 50. So I know this top portion is 1. Square root of 1 is 1, of course. Okay. Now I'm going to factor tree to see what I can pull out of this 50. So I get 10 and 5, 2 and 5, so I can pull out a 5, leaving a 2 underneath, so I get 5 square root of 2. Okay. Now that's basically my answer, but remember, you cannot have a radical in the bottom, so I need to multiply by square root of 2 over square root of 2 to rationalize. That's one reason why I wanted to pull this out ahead of time so I get smaller numbers. And this is going to give me square root of 2. And this is going to be 2, so 5 times 2 is 10. So this is my value for sine of theta, whatever theta this is. So that's the half value of theta at that angle. So that is number 2. Okay, I'm going to be working out number 4 here in concept 5. Now it just so happens I just chose 2 of them that dealt with finding sine. The other ones are cosine and tangent. You just follow those formulas, so we kind of follow the same technique, only we use those formulas. If you need help with those, please ask in class, because I just randomly chose 2 sine ones instead. Alright, so I'm going to attack this the same way. I'm going to first look at my angles over here. I know my angle theta is between 90 and 180, which tells me that the half angle, if I use that little section on top to help me out, is going to be in quadrant 1, which means that sine is positive over there. Okay. Now once again, I gotta use a triangle, so I'm going to get my triangle out, and I'm looking at cosine theta, which I know is in quadrant 2. So my angle is going to look like that. Okay, once again, if you need to draw in your x and y axes, there it is. That was bad. I'm going to do that again. Okay, quadrant 2, and this is going to be angle theta. Okay, and this is cosine, which means this is adjacent, and 19 is the hypotenuse, and the square root of 105 is negative because the x value is going left, so it's a negative. That's important not to forget there. Alright, so now I got to use the Pythagorean theorem on this one. So I got, I'm going to call this B over here. So I got square root of 105, that's squared, plus B squared is equal to 19 squared. Okay. So this square and there's a square root, so this is 105 plus B squared equals 19 squared is 361. Okay. And if I subtract 105 from both sides, I end up, I'm running out of room here. I'm going to end up with B squared is equal to 256. And if I square root that, I end up with B equals 16. So B is equal to 16 over here. Okay, so sometimes you have to use the Pythagorean theorem to figure that out. Now from here, it's just using my formula, guys. Okay, so a lot of hard work is kind of done. So I'm trying to find sine, so I'm using sine of theta, half of theta is equal to, now I'm dealing with the plus, so the plus portion, 1 minus cosine theta over 2. Okay, and just let me plug that in. So now I'm going to plug the values in from over here. So I get 1 minus, and cosine of theta okay, which is negative square root of 105 over 19 all over 2 big square root. Okay, that's kind of sloppy there. See if I can redo that. Alright. What I like to do here is I like to just go ahead and times by 19 over 19. What that's going to do is it's going to get rid of this fraction, okay, which I just don't like to look at. It works it out much easier for me if I don't have that. This may be an extra step for some of you, but like I said, I kind of like it. So this turns into, when I multiply, turns into 19 plus negative times negative, so we're going to take that down. Square root of 105 over 19. Oh, nope. Over 28. Sorry about that. Over 38. I misspoke. Okay, and that's pretty much where we can stop. Of course, you could write this as 1/2 plus square root of 105 over 38, but it's not going to look any better. So that is my final answer for that one. So if there's any questions on these, please bring it up in class. Otherwise, you should be able to do some of these practice problems. If you want to wait till class when I cover the double angle stuff, that's fine. We can work on um, those practice problems in class. So hope that cleared up some things. If not, please bring questions to class.